In this more advanced example, we'll be using list comprehensions as well as reduce to answer some questions about text processing. Once again, we have this message here, a message that we have seen last time, and here we're being asked to use list comprehension to remove or blank out emails from this list, from this text. Okay, so once again, we can think about this as a sequence of steps. Basically, there is a function that we need to apply, and this function is a masking function. We need to mask our emails from a list of words. There is a filtering function. We don't need to filter if we are masking, so we can either mask or filter out the emails. Let's do masking this time. And lastly, we need to reduce the list to one string. Okay, so I'm going to do it this time using a function mask word. What I'm going to do, if I'm going to write a condition here, if at in word return length of word times star, else return word. You know, optionally we can write this in one conditional expression in Python, and this is something we've done in the previous lecture, so I'm going to do it using a function this time. And now what I'm going to do, I'm going to mask each word in the list of words, right? So I need to take my message here and split it. So I'm going to call the function split, and that's going to, for word in message.split, create a list of words, and then I'm going over each word, applying the function mask. That's mapping the function mask to each item in this list, and I can see here that the emails are masked. Well, the next step is to join these together. So I'm going to use the function join. We've seen how we can write a reducer to do it. We can do that, but we're going to write a reducer for the next task. So for this task, we're going to just use the built-in join function, a function that we call in a string that's basically saying take this list and join it with a white space. The next question is asking us to report the word that has the length, the longest word, the longest length, the longest word in the message, which is basically this email. Okay, so there are a couple of ways of thinking about this operation using the basic, conceptual kind of functions. We can think about this as a filtering operation. It basically go over each word and only keep words that have length equals to the maximum length. So then we need to figure out the maximum length of all words in this string. So then we have two steps: figuring out the maximum length and then filtering out only words that have length equal to that maximum length. So the first, figuring out the maximum length, we need first to calculate the length of each word in our sequence words. So I'm going here to actually split and save it in another variable called word, so I don't keep splitting the message back, again and again. So length word for word in words is basically going to give me a list of numbers. Again, this is a list comprehension, and we can conceptually think about it as mapping a function length to each item in this list, mapping or applying a function length to each item in this list. Okay, now next we need to get the largest value of these. So this is a reducing operation. We can think about it as, reducing by taking out the maximum value of each two consecutive values. So what's the maximum of 2 and 2? It's 2. What's the maximum of 2 and 8? It's 8. What's the maximum of 8 and 2? It's 2. What's the maximum of 8 and 4? It's 8. What's the maximum of 8 and 6? And so on and so forth. So we can write a reducer here to do the maximum for me. So what I'm going to do here, I'm going to write a reducer here that goes over this list, or the reduce function takes a function that's the reducer, and my function here is pretty easy: lambda x and y will return x is greater than y, otherwise this will return y. That's basically the expression here. X is X greater than Y, otherwise Y, and reduce this list using this function here. Well, we need to import reduce from function tools, so I'm going to import reduce from function tools. Okay, and we get 21, so the maximum value here is 21. I'm going to save this in a variable called max length, and max length is now 21. Now, we don't need to do this. Calculating the maximum, actually, there is a built-in function called maximum that does it for us. I just did it here for the sake of, conceptual consistency, saying that finding out the maximum from a list of values, it's reducing this list of values to one value. But actually, there is one function here called maximum that does this for us. So I can do maximum length of word for word in words. That's the maximum value in this list is going to be 21. So we can use the built-in maximum function if we wish. There is nothing to be ashamed for using a built-in function. You should be using whatever give you back the solution in a more efficient manner. But that's conceptually the same as reducing. So I'm going to keep both of these for you just to kind of compare and contrast side by side. Okay, now once we have the maximum length, the next step is a filtering step. I want to go over each word in my word list for word in words. Once again, this thing is going to give me the list of words itself. The missing step is the filtering. I want to say if length of word equals to this thing, maximum length, meaning only keep these words that have a length equals to the maximum length, and this is going to be doctor.funpython.org. Now, you can see that this filtering operation resulted in a list, and this is because theoretically speaking, there could have been multiple values, multiple words that have the same maximum length. If I only want one of these words, I can do just 0, because I know here there is such a word in my list, and which gives me one word. The other way to do it is to basically use a reducer that instead of taking numbers takes words and give you the word that is longer than the other word. It's kind of like building our own customized maximum function that operates on words rather than operates on numbers. So here's what I'm going to do. I'm going to define my function called longer that takes two words, word 1 and word 2. And it's basically going to do the same thing as this one, except that it's going to return the word rather than returning the length of the word. So what I'm going to do here, I'm going to LW1, length of word 1 is length of word 1. LW2 will be length of word 2. And then what I'm going to do here, I'm going to longer is word 1 if LW1 is greater than LW2, else word 2, and return longer here. So it will examine the length of the word when it determines which one is longer, but it's going to return the word itself rather than its length. So if I do longer Python and Java here, I'm going to get Python, but if I get a longer Python or JavaScript, I'm going to get JavaScript. Okay, so far so good. What do I do with this function now? Now I use this function to reduce my list, because my list here is a list of words. So what I'm going to do, I'm just going to reduce it. I'm going to reduce this list using the function, and I'm going to get, lo and behold, this doctor for fun.python at Python because it's the longer word. So it's just using one function reducer to reduce this whole list of words. Then the last question is asking us to do the same, but exclude emails from the calculation. So we don't care about emails. Emails are longer than many words usually, so we want to look only at words which are not email. So we can either do it, we can fine-tune the two strategies here, the two approaches. Approach number one is to calculate the maximum length here. Nope, not this one, the maximum length. But here, when I do the maximum length, I'm going just to have just an optional if in my list comprehension because I want to exclude emails. So I'm going to say if at not in word. And now my maximum length is the maximum length of words which are not email, which happens to be 8 in this case. The next step is the same because I just want to get list of words that have length equal to 8, and this list of words there is only one word which is possible. Okay, well the next step is now this the second strategy is almost the same except that I need to reduce and filter, right? So this is reducing a list. Before I reduce a list I need to filter this list, so I'm going to filter using a list comprehension. I'm going to say word for word in words if at not in word, to basically create another list that filters the original list and reduce this new list rather than the original list using the function longer, which should operate as before.